Great. So let's get started. So I said I'm presenting these two repositories, eLabFTW and RSpace, that are now integrated with Galaxy. Those are electronic lab notebooks, which were there were none of them previously integrated with Galaxy. So that's a great thing. And also on the other hand, the Archaeographic, which is our middleware for distributed compute. I mean, this is not something that I achieved alone, so I also want to thank the RSpace team because they provided some crucial component that I will talk about later. And also Tilo Matis that had came to visit the Galaxy team and kickstart that collaboration. And also for the ARC integration, I want to thank Mike and Pedersen from the University of Oslo that provided support and ARC instance to test against and a lot of help really. Repositories, maybe if you are on the developer side, you might know them as file sources because they recently decided to name these repositories, at least in the UI. And these are locations that you can import and export files from or to, basically. So using repositories, you can populate, using files from repositories, you can populate a history. You can also export files to repositories to share them. For example, if you share to Zenodo or Dropbox, then other people can access them. Or you can export whole histories for archival. There is a wide catalog of repositories available, and as I said, the ones that have been integrated are RSpace and eLabFTW, and those will be the ones I'm talking about. But first, it's important to know what an electronic lab notebook is. So they are the electronic version of the classic lab notebook that whose purpose is basically to record the research process. You explain your hypothesis, you carry out experiments, and then you note down what you did and what happened. They also included the analysis of results and their interpretation. And the electronic lab notebooks are the electronic version that obviously has some advantages, like you can very easily access the data, find the data, access the data, and reuse the data. But there are also some things that you cannot really achieve without the electronic version, or it's not so efficient, that is collaborating with other peers, I mean, real time, integrating with instruments and data sources, and also manage lab resources in the sense of what is available. If you want to book instrument for some specific data, these are also things that the electronic lab notebooks do. So there were no ELNs integrated with Galaxy, and now we have RSpace and eLabFTW. Let's say the biggest plus of this is that for some kind of experiments, especially if they involve the lab experiments, then you need to be very careful when tracking the specific samples that you use, and also the instruments that you use. You have to book them, etc. So it's not really, it's a good complement to the functionality of Galaxy that is centered around analyzing data. Let's start with eLabFTW. This is the list of features that I just took from their website. The most relevant, I would say, are the basically, I mean, it allows you to record your experiments. Then it has also an inventory, laboratory inventory management system, which will track the samples and the instruments, and you can book instruments, but it also has some extra neat features regarding security and reproducibility and so on. So, I mean, if you are interested, just check the website. There are some screenshots there about how it looks like. Oh, oops. Okay. Okay. So the integration with eLabFTW works in the following way. So for each experiment or resource, if you open click actually one of them, you would see besides the details of the experiments and or the resource are either samples or instruments. There's also a section on attachments that you can actually put files in, and the integration basically allows Galaxy either to take the attachments that are for an experimental resource or to attach something to them. That's say the cleanest way that this integration could work. The setup is quite easy. Basically, first you go to eLabFTW, and there you have to generate an API key. And then you go to the usual place in Galaxy, that is your user preferences on the top right side. If you click on preferences, then you see this screen here, where you can then click on manage your repositories. Then you click on create. You choose what kind of repository you want to add, in this case, eLabFTW. And then you provide the information, I mean, the name and description. That's important. You can choose any endpoint you want to, so you can connect to your own instance, because since eLabFTW is open source, you can also run your own instance for your lab. And yeah, basically that's it. You put your API key, and then you're ready to use it with the usual UI that you have to upload files to Galaxy. The usual thing, you click the choose remote files, and then it will be on the list. And you will see that each, I mean, you have two artificial folders, let's say, one for every experiment, another for resources. And then if you click one, you see a list of all of them, and then the attached files inside. And you can use it as you would use any repository. As I said, you can also export histories, or you can also export datasets with the export datasets tool. And probably, I guess I'm missing some other use cases, but as I said, it will work as any repository. And then let's talk about the RSpace integration. So this is also an electronic lab notebook, but also has a wider focus as RDM platform. And one of the best things is basically the great amount of integrations that are available with all sorts of tools. Yeah, said we had a meeting with them, so we actively collaborate with them. Not only, so this is not actually the only integration that exists with Galaxy. There are two. The one I'm presenting is the repository, but they also developed from their side integration that consists on being able to upload files from RSpace, but also launching workflows. So they can, from RSpace, you can basically automate the whole analysis. Like you define a workflow in Galaxy, and then you can log into RSpace and repeat your analysis with every sample. For our integration, they provided an important component that is a PyFile system module. PyFile system is a library that Galaxy uses to or it's integrated with to develop their repositories. Although now we also have a more modern alternative, FS spec, and they already had this component ready, so it was not so hard, let's say, to make this integration. The scope of the integration is similar to the eLabFTW one. So they have a special component in RSpace called the gallery, where you upload files, and then once in every document or notebook that you define in the workspace, you can reference these files. And so that's where you will put the files with Galaxy, or you will take them from. The setup is very similar. I won't go through it again. Generate API key, go to your preferences, choose the proper option, and your API key is exactly the same. Also because it's open source and you can also have your own instance. One thing that I didn't mention before is that you can actually, because of how Galaxy works, you can add multiple of any kind of repository. So if you work in different labs or have different instances, you could have multiple RSpaces or multiple eLabFTWs, which may be neat. And yes, the same story. I mean, it's exactly the same story for how to use it. And that's for the repositories. Now let's look briefly at the Arc integration. So first, let's talk about Arc, and then let's talk about the job runners. So it's okay. Now it seems to be working. So Arc, let's say, I mean, first we should talk about the worldwide LHC computing grid. This is basically a distributed computing system from where CERN is involved. So it basically works, I mean, as an organization first, by joining several institutions together to pool their resources together for the analysis. It has been existing in the year 2000. Now there are about 160 production sites using the, I mean, the grid, and also Arc. And you can make a site for the WLCG, work with either Arc or HT Condor. Those are the two recommended distributed systems to run a node. And Arc allows to submit jobs to remote HPC systems because it's a middleware. That means that you have it's like your entry point. Below Arc, you have other systems working like Slarm, or but it's not only, let's say, because it adds also some extra features on top of being a middleware for the underlying batch system that you have. So, for example, it also allows to have dedicated storage that is managed by Arc, among other features. I mean, I'm not actually involved in the development of Arc, so I cannot tell you so many details. But I mean, that's two important aspects, I would say, is how the authentication works here, because that's also linked with the previous presentation. I think that would be a nice addition, actually. I'll comment on that on the next slide, or 2 slides. And it works either with JSON Web Tokens or X509 certificates for authenticating the users that submit jobs. And then it also has the particularity that you can, let's say, in many batch systems, you have to upload or and download the data yourself. And with Arc, you can delegate this job to it. So you say where you have to take the data, it has to take the data from, and where it should put the data in after the computation is done. And yeah, I mean, Arc supports can be on top of Slang, can be on top of HT Condor as well, so it can work with these kinds of clusters. Also with PDS and with even with Altair. So the a Galaxy job runner is what executes the Galaxy jobs. Those are the plugins that execute the Galaxy jobs, and Pulsar allows to it's a specific or special job runner that allows you to run the I mean, for Galaxy, of course, it's a separate application that you run on a separate server, but Galaxy sees it as a job runner where it can send jobs, and these jobs get sent to a remote site where they get executed. And it can work either I mean, in the end, it also has, it's a sort of middleware, so it will also have below it a batch computing system, for example, the typical ones, HT Slam, but also it can work in the as a client that basically submits the jobs to cloud systems as well, so like AWS Batch or Kubernetes, or and in the same fashion it works with Arc. So it's basically submitting jobs to Arc and just waiting for them to be completed. I mean, if you have questions, I think you can ask Marius about the technical details of operating modes and or other people from the Galaxy team. They will be able to clarify quite well, I would say. Yeah, that's the how do you use this integration? It's low level at the moment. That means that let's say if you want to set it up, you need app intervention. So on the one hand, you need to define a first job runner. So that's I said the our job runner is based on Pulsar. So this is the path in the code that you would define. And for to load the job runner, and then it has several configuration options. First, an important thing is it only runs containerized workloads, so you need to use it right yes or yes. If you don't set it through, then it will fail. Then you can configure an endpoint, any endpoint that you wish to use. Then also for the authentication, as I said, it can use either JSON Web Tokens, which are actually a kind of OIDC token or X509. So we decide for the integration to use OIDC tokens because Galaxy already has login providers based on OIDC. So that was the, let's say, the most frictionless way. But it would be interesting to have support in the, I mean, to support storing credentials for specific for a job runner in the same way that it's done for tools. And then there is also an option for admins to define a key in the user preferences so that they can add a form where the users can actually configure the endpoint or the OIDC provider. So it's either admin fix or the admin can give freedom to users to decide what are the options. So it's a lot of flexibility, but yeah, I mean, I guess the integration could get better as we figure out, or I hope we figure out in the future how to do this for job runners as we did for tools. And just, I mean, that's all from my side. Thank you. Do you have any questions?
For the integration to with RSpace and eLabFTW, so the generation of the API key, and so each user has to do this by herself, or can the admin set this up for all user, current and future?
You can set it up for everyone because it's a regular repository. So let's say, I mean, actually, that's something I should also comment about the availability. It's a very important point that I missed. We have enabled these integrations, RSpace and eLabFTW in Galaxy Europe. I think in org and AL, for example, they are not enabled. I mean, but it's on part of the Galaxy code base, so I mean, it just have to be enabled if they wish. But there are two ways that you can define or use a repository. There are the so-called file source templates, which are the what we are using in Galaxy EU now, which is what you make available through this menu. So, I mean, these are the file source templates that define how you can configure a file source. This is basically what you are defining in the template. And otherwise, you can also tell an admin to just define a file source for everyone instead of a template. So it will be available to everyone. And there, you can basically hard code the API key. but then you are the same user. So it's kind of not so nice. I mean, there will be a middle ground, let's say that is define this, and I think if I'm not wrong, leave the API key, let's say blank, and put a form in the user preferences in the, I mean, in this place where you can put custom forms so that the API key is read from here. So that would be, I guess, the most, the best middle ground, I would say, yeah.
I mean, I think it makes a lot of sense.
Yeah.
I mean, that would work, but I think another way to do it is have the same sort of language where you say, as Ash and Leheza were presenting, you have the same language where you say, this is a credential and it is a credential. So like the admin says, this is available, it will appear in your file sources, and the moment you go there, that's why you need a key.
Yes, definitely. I mean, same story for your brands, I will say.
Yes.
We'll figure this out.
Thanks for interesting talk, but I'm a bit confused about the ARC run.
Yes.
Since you need a user preference key or whatever, does it mean that it's usable only by some users, or can a user select it somehow?
So let's say there is a logic in the job runner. This is the following. If you define you as an admin, let's say in this menu that I should have included a screenshot. If you click on manage information, you as an admin can define a form, a custom form, so the user can enter any information they want. And then this is defined by a string. Let's say that if you want to extract information from this form, you let's say give a name to this form. That's the user preferences key. So if you are an admin, you can say the runner should extract information from this form. But if you don't define any key, then it will use what you hard code here. Yeah. So that's what you are free to choose. Let's say.
As I see now, the RSpace and eLabFTW is used as file sources, right?
Yes.
But they are actually also have a lot of metadata in the eLabFTW. Or do you also, is there a way to also import all the metadata together? Like, I don't know, as tags?
No, at the moment, no. And that would be a nice thing that we could work out with RSpace, for example, since they are further integrating with us from their side.
Yeah, so what they are also planning and what they have, I mean, maybe Eli can tell us more. So they are also working on row crate integration. So if we can manage that they actually push a row crate in Galaxy, or that we import a row crate from them with the work that David has been done with the importer, right? We could maybe take more metadata plus the files and do smarter reasoning on the Galaxy side with the worksheet that John has presented yesterday. Right, so I think many people are working on this direction of how do we get more metadata from external resources and then do smarter reasoning in Galaxy, maybe recommending workflows, maybe recommending tools, and so on. Are there any further questions? And let's please thank José again.